Are you looking for a way to evenly cool your prints so that you can get crisp edges and overhangs like this? If so, I've got just the thing for you. Mini cooling fans. Yeah!
Behold, the best cooling fans you can possibly put on an Ultimaker.
So my search for a good cooling shroud started when I realized the Ultimaker shroud was pretty awful. The stock one that comes with it doesn't really do a very good job. So I hopped on Thingiverse and found this gem. Now this actually worked extraordinarily well for shorter prints, but when I started getting into prints that take about 5-6 hours, it started heating this up so much that it would bend up, and actually it ended up touching the hot end and melting into the shroud, which kind of messed it up. So what I decided to do was to start from the ground and start experimenting with my own shrouds and figuring out what works, what doesn't work, and I wanted to get a solution that would work better than anything else out there that I've seen.
So, seeing that the original Ultimaker fan sucked really bad, I went ahead and looked to the Ultimaker 2 and its dual fan setup and thought, haha, the holy grail, this is what I need to do. So I soldered two 40mm fans in parallel. Alright, so these two beauties were my first design. Now there's a lot of things that I didn't really like about them, but they were a good first step for me to realize what I did like, what I didn't like, things that worked well, things that didn't. But before I developed it too much, I ended up having this really bizarre problem that I thought was interference between the thermocouple and the PWM signal of the fans. Here I'm turning on the temperature for the nozzle, that way you can see the effects of the fan on the temperature reading. So I'll go ahead and crank the nozzle up to get it nice and warm, and then as it's heating up you can see the temperature slowly rising. But here's the deal, when I go and turn the fan on to a slower PWM than 255 or at 100%, it starts giving this crazy interference and the temperature rises way too quickly and actually overshoots the set temperature and then keeps rising even past the set temperature. Alright, you can see that the fans are on now, and when I look back at the temperature, it's jumping and increasing way too fast. This is the interference that I'm getting, and during a print it can't ever hold a steady temperature and it's constantly jumping up and down. Now, because the only solution I had to this crazy temperature jumping was to turn my fans on full blast, I ended up cooling my heated bed down too much so the prints kept popping off. And this is when I turned to the micro fans. That's right, 18.4 millimeters. This thing was tiny. The only caveat to these micro fans is that they ran at 5 volts. Now, I ran them in series so that I thought that the 12 volts that would be supplied to them wouldn't be too much more than what they could handle. But the Ultimaker puts out 19 volts to the fans. And of course, I didn't realize that it put out 19 volts to the fans until after I ran the little fans for a few minutes. They were blowing great, really hard, everything sounded good, but then I released the magic smoke and the fans no longer worked. So at that point I was like, alright, I'm going to get smart about this. I'm going to get a 5 volt regulator and I'm going to regulate whatever voltage I'm getting to the fans down to 5 volts, then I can just run them in parallel and everything will be great. Well, that didn't work so well either. Dropping from 19 volts to 5 volts generates a lot of heat, and that little 5 volt regulator got hot quick.
Once I realized the voltage regulator wasn't going to work how I wanted it to, I decided to pull everything off and start over. So I was unsoldering the voltage regulator, and I accidentally crossed the positive and negative terminals. Now, I left the Ultimaker on, I just turned down the PWM. So the fan wasn't spinning because the PWM was turned down, but it was still getting voltage from the Ultimaker. So when I crossed those two leads, I ended up frying the Darlington Transistor that actually drives the PWM signal. So once that was fried, it just got 19 volts solid. There was no modulation of that voltage. Anyways, so whenever you turn on your Ultimaker, the fans would turn on full blast. I would try to turn them down through the PWM settings from 255 to 0, whatever. Wouldn't matter. They were still getting 19 volts. There was no regulation. It was just busted. It took me a long time to figure out what exactly had happened, but once I did, I ordered a new Darlington Transistor from DigiKey. I pulled the old one out, soldered the new one in, everything worked fine. So that was a pretty easy to solve solution once I figured it out.
This little jewel is located right next to where you actually plug in the fan into the main board. Now, when it goes bad or when you short it out, the fan will default to 100% on all the time. So I broke out the solder sucker and pulled me off a Darlington Transistor. Once I had wrangled the bad Darlington Transistor off the main board, I went ahead and soldered a new one in that I ordered from DigiKey. Here's a pro tip from someone who's taken the Ultimaker control board off way too many times. If you take some tape and put it through the nylon spacer and then slide that onto the bolt and the spacer stay sticking straight out of the bottom, so you can easily slide the control board back on. Otherwise, it's a pain to get everything lined back up.
Once I got the new Darlington Transistor in, I expected it to be smooth sailing. My boat never sails smoothly. I tried different fans. I tried small fans, I tried big fans, I tried fans unmounted from the print head and on like as far away from the thermocouple as possible, and I was still getting this really bad interference. And all the forums that I was reading, everyone was saying, oh yeah, it's just the PWM signal from your fans, your fan power cables are too close to your thermocouple wires and there's radio interference and blah 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 blah. And so I played with that, I fought with that for such a long time. And what ended up being the solution was, when I installed my heated bed, there's this thing in your Marlin software it's called fast PWM. And what it's supposed to do is increase the PWM signal so that there's less interference. Well, for some people, which is me, it makes it way worse. I wasn't having any interference in the first place, and when I switched over to the fast PWM, it ended up making this crazy interference problem where everything still worked, but the temperature on the hot end, once the fans kicked on, would jump like 10 or 15 degrees until it overshot the actual set temperature, and then it would just like bounce like 10-15 degrees high and low. It was not stable. It made prints look terrible. It was really frustrating, and that took forever to figure out. So if your printer is having these weird temperature variables or variances with the hot end and you think it's interference with your fans and your thermocouple, make sure and check that the fast PWM is turned off in your Marlin software. It's a really simple thing to check, and it might save you a lot of trouble. So once I was able to figure out all those other crazy problems, I was able to move forward with this project. Now what I ended up trying to do was find a small fan that was 12 volts. So I got this guy. Now this is a little bit bigger than the micro Raspberry Pi fan, but it is still way smaller than the stock fan. So we're winning here. This is a good option. So I started making a bunch of different shrouds for that guy. One looked like this, another one looked like this. They're all really kind of bizarre shapes, but I was just trying to figure out how to mount it, what angle, what size nozzle, all that stuff. What I ended up with, which I'm pretty proud of, is these guys right here. Now these work really well. These are printed out of ABS. Now ABS has a higher melting temperature, so they don't warp near as bad. Plus, they're not as heavy, so you don't have as much weight trying to bend them down when it heats up. These guys have worked awesome so far. I've printed a lot of stuff, including this guy with them, and it's been phenomenal. I can't say enough how awesome these are. We've got bolts to hold the fans on, just 2, so we're not using 4 bolts because that's unnecessary. You could probably even get away with doing 1. But these fan shrouds print without support. They print with the holes already in them. All I had to do is drill out the holes on the actual fans to make it a little bit bigger so that I could just put the bolts through and then thread them into the actual fan shroud. Other than that, everything just plugs into Ultimaker and runs, because you can supply the same voltage that you do with the big fan, and the PWM works with them. Everything works great. They're half as heavy. These 2 fans with the 4 bolts and the wiring harness and all this stuff weighed half as much as the original Ultimaker fan, shroud, and all the hardware that went with it.
I first printed the shrouds out of PLA, but I then went back and reprinted them out of ABS.
All the shrouds that I printed out of PLA eventually ended up warping and hitting the build platform. That was no good, so I moved over to ABS. I knew that ABS had a higher melting point temperature, so that would keep it rigid at the hot temperatures. Now, printing in ABS can be kind of tricky. The biggest thing is to getting it to stick to the build platform as you're printing. Well, I found this. This is really cheap Elmer's stick glue. This stuff works awesome. You just spread it down over the build platform before you print on top of it, and it's almost like PLA. There's almost no warping.
Alright, so here's everything all bolted up and ready to go. One of the features that I'm particularly proud of this design is how you mount it to the print head. Check this out. My shrouds use slots instead of mounting holes. This allows you to slide it onto the back post and then rotate it around and it locks into the front post. This creates such a tight interference fit you don't even need nuts to hold it in place.
I really enjoyed working on this cooling fan project. Now, there's a lot of bumps in the road along the way, but with each bump, I learned a really valuable lesson. Some of the big lessons I learned were, number one, don't turn on fast PWM. That stuff causes a lot of temperature interference and will mess you up. Number two, if you have a heated bed, don't use a bunch of cooling fans or fans that put too much air down because you'll cool the print and it'll pop off. I also learned a lot about printing with ABS. Thanks for watching the video. I learned a lot during the entire process. I hope you picked up a few good things from the video. If you have any questions, put them down in the comments below and I'll be sure to answer them. Also, while you're down there, go ahead and click on that like button, click on that subscribe button, check out all my other videos. I have a new Twitter account and a new Facebook page. Check those out. I post stuff on there that I'm not able to put in the videos.